So our topic today is solving quadratic equations. So we have vocabulary first. First of all, you need to know when I'm solving a quadratic equation, what am I doing? What are you doing? You're finding the zeros of a function. So what is a zero of a function? Well, it's a value of the input x that makes the output f of x equal 0. In other words, it's a number that if you put it into the equation as x, your answer should be 0. So the zeros of a function are actually the x-intercepts. So if you were to graph a quadratic function, you should know from last year that quadratic functions make parabolas, and that the parabolas can have up to 2 x-intercepts. So it could have 0, it could have 1, or it could have 2. Most often, it has 2, and those are the zeros. So that's what values you could plug in for x that would give 0. Now it's possible that if the whole thing was above the x-axis, or it was turned the other way and the whole thing was below the x-axis, you might have 0 x-intercepts. Also, if it just touched the x-intercept, like y equals x squared, and the vertex was on the x-axis, then it could have 1. Okay, so, but most often it's going to have 2. Okay, so some different ways that you can find zeros. So we're going to learn a lot of different ways, but in this particular video we're just going to learn how to find the zeros by factoring. Since we just finished learning how to factor expressions, now we're going to use that topic in order to find the zeros. So I start out with something that looks like this. So you're used to factoring this expression, so now we're just turning it into a function. So we turn that into a function. First we're going to set the function equal to 0. Alright, I did that. Then I'm going to factor it using the methods you learned previously. The new step is that I'm going to set each factor equal to 0. So I have x minus 2 equal to 0 and I have x minus 6 equal to 0. So I set each part equal to 0 and then I solve each equation. So if x minus 2 equals 0, then x is 2, and if x minus 6 equals 0, then x is 6. So therefore, my two zeros of this equation are 2 and 6. And I can always go back and check my answer. So if I plug in 2, I get 0. And if I plug in 6, I get 0. So if those are the correct answers, you should always get 0, because when you solve a quadratic equation, you're actually getting the zeros, which if you remember, it's the input value that makes the output 0. Alright, so let's try this one. So here is our quadratic equation, and we're going to do step 1. So step 1, set it equal to 0. So here we have 0. Step 2, factor it. So this one, I look at it only has 2 terms, so I know I can take out a greatest common factor. I'm going to check if I can take out a GCF, and I did. So I take out the GCF. Step 3, I'm going to set each of the factors equal to 0. So 3x equals 0, and x plus 4 equals 0. Step 4 is that I'm going to solve each part. So if 3x equals 0, then the x must be 0. And if x plus 4 equals 0, then x must be equal to negative 4. So just to let you know, when you're solving this, if I were to graph this equation, the graph would come up looking similar to this. And those answers are actually where it crosses the x-axis. So it will cross at 0, and it will cross at negative 4. And since it has a positive leading coefficient, I know that it actually goes upward. Okay, so again, I can check my work. So I got as my answer 0 and negative 4. So I plug in 0 to my original function, and I got 0. And I plug in negative 4 to my original function, and I get 0. So remember, the answer to a quadratic equation are what are the inputs that you can put in as x, and when you solve it, the output is 0, and that's what the solutions are. Alright. We cannot forget about special products. So when you're factoring, you learned about special products, and these are going to help you find zeros. So let's say you got this quadratic equation that looked like 9x squared equals 1. So the first thing you want to do is you want to rewrite it in standard form. So put it in standard form with the highest leading coefficient, and of course set it equal to 0. And then you're going to factor. So once I start factoring this, hopefully you realize by looking at that it was a difference of two squares. So I factor it using the rule for the difference of two squares. Once I do that, I'm going to set each of the factors equal to 0. So I set both parts equal to 0. From there, I solve each equation. So when I solved this equation, I got negative 1/3. And when I solved this equation, I got a positive 1/3. So the two x-intercepts are negative 1/3 and positive 1/3, which are also the zeros of this equation, which are also the solutions to this quadratic equation. Okay, so x-intercepts, zeros, solutions. Those three words are synonymous. Okay, another special product. So hopefully you remember there was one other special product that was perfect square trinomials. So we're going to do an example of what this would look like. So of course you're going to rewrite it in standard form. So I have 8x squared. I moved the 40 over there, so that became negative 40x plus 50. So put it in standard form and of course set it equal to 0. And then I'm going to factor out a GCF, because right away this does not look like that's a perfect square trinomial, but I know I should always first check if it has a GCF, okay? So, does it? Yes, it does. Okay, so take out a 2, divide both sides by 2. So I took out a 2 and I got 4x squared minus 20x plus 25. And now I'm going to divide both sides by 2 because I have an equation, so I can just go ahead and get rid of that, so that goes away. Now I'm left with this, which hopefully you realize that is a perfect square trinomial. So by definition, their first term is a perfect square, their last term is a perfect square, and the middle term is either negative 2ab or positive 2ab. So that does work. So therefore the factors are 2x minus 5 and 2x minus 5. So I have two of those, so I went ahead and solved it twice just so you know there are two of them. But I only end up with one solution. So the answer is actually 5/2. So again, the answer is what can you plug into this? What input can you plug in that will make the output 0? So if I plug in 5/2 here, it will give me 0.